thanks for waiting. It's taken us a few minutes to get going with this. But welcome everybody. It's a pleasure to be here. Really exciting first Couchbase Chennai Meetup. We've got a couple of exciting presentations lined up for today just to get started with Couchbase. Introductory presentations just to sort of introduce you to the technology and to tell you, just to give you an overview of some of the really cool things that are there in the Couchbase database system, both on the server side as well as on the client side. We've been working with it for a while now, and we're really excited with the technology that Couchbase brings to the table. We want to reach out into the community here, the developer community in Chennai, and really share some of the knowledge that we've gained, and also perhaps to learn from everybody in the developer community in Chennai. I'm really delighted that we've got one person from Couchbase itself here, Karthik. Karthik Babu Shekhar is from Couchbase, brings huge amount of experience and skill to the table, and we're really excited that he's here as part of today's presentation. He's going to be doing the first presentation, and soon after that we've got a couple of people from RedBlackTree, Anish Matthew and Kadambari Andalagan. They're going to be doing the second presentation. So in the interest of time, I think we'll just get started. But before we do, just like to say that this is a very, very informal gathering. We want to talk about tech, we want to talk about NoSQL, Couchbase, we want to sort of exchange ideas, talk about some of the problems that we faced at work that you guys do, and hopefully that will lead to a lot of sharing of ideas and lead to a lot of learning. So we want this to be a very informal gathering. Want you to feel totally comfortable, and we want to keep going with this, right? So we want to make this a regular thing where we'll talk about, in meetups to come, we will talk about more advanced topics. We want to talk about big data. We want to talk about some advanced mobile stuff. We want to talk about machine learning. So we really want to expand the scope of the discussions here. So so just feel free to ask questions, though I'll allow the presenters to sort of run their presentations, but feel free to join in the conversation after the presentations as well. We want to just hang out, just meet everybody. So so this is a social gathering as well. So please be very comfortable and welcome once again. Just a small administrative note, we're going to have some tea and coffee and stuff like that, so please feel free to help yourselves at any point, right? So so without wasting any more time, I'll let Karthik take over.
Karthik, I'm a solution architect, worldwide field operations at Couchbase. So I also do professional service consulting. So you can follow me on Twitter. So I'm pretty much active. You can get some latest updates on Couchbase. It's SKB here. So before I start, I wanted to understand how many of you have not heard the word NoSQL. So which means that everybody is quite aware of the NoSQL technology. So I can probably skip few slides, saving some time. So just a brief note why we need NoSQL. So as you know, NoSQL is not only SQL. So the first requirement is you don't need to define the schema before inserting the data, and also you don't need to provide, or you don't need to have change the data runtime. For example, you don't need to alter the table like you do in the RDBMS, right? So you can have a flexible schema in NoSQL. That's one of the requirements with changing new web applications, where there is a huge requirement for a flexible schema. And as you have more mobile users and more application users, you need to have the queries being distributed, right? So you need to have a system which manages hundreds and thousands of users who are logging in, and synchronization across multi-data center. When you have DR, disaster recovery, you need to cater how the data is being synchronized. So I don't want to talk about the RDBMS, just a simple difference between an RDBMS and NoSQL. So as you know, in RDBMS you require a rigid schema. So in NoSQL it's schemaless, or like it's a flexible schema. So RDBMS you typically scale vertically, and in NoSQL you can scale out. So in Couchbase with the version 4.0 you can do both. You can vertically scale and you can horizontally scale. So we call it as multi-dimensional scaling, which I'll be talking about it a little later. So RDBMS, the size, if you could see, typically it's in terms of gigabytes and terabytes, whereas in NoSQL it's in terabytes and petabytes. So in RDBMS you would need a special DB class servers. In NoSQL you can work with commodity hardware, and in RDBMS you need to have the data normalized, and NoSQL it works on a denormalized data. So history of Couchbase. So Couchbase was actually is a combination of two products merged, Membase and a fork from CouchDB. So CouchDB is different than Couchbase. So we took a fork from CouchDB, and Membase is actually a database which was formed, which was created by the founders of Memcached. So adding a persistence layer on top of Memcached. So Northscale was a company who developed that Membase product, and then combining it with CouchDB formed the Couchbase project. So you have a key value and a document store. So what does Couchbase provide? So Couchbase offers various use cases. So starting from high availability cache to an embedded database. So typically customers start with high availability cache. So as I mentioned, Couchbase has its root in Memcached. So which means that it's a drop-in replacement for Memcached. So you can have Couchbase handling the session data for on top of RDBMS. If your RDBMS is struggling to handle millions of users, so you can have it as a high availability cache. So we are using Couchbase is used in one of the world's popular companies backend, catering over billions of users. And you can extend the session store to a key value store to store a profile data of users, not just a session data. You can store the profile data as a key value store, and with having a persistence layer along with the Memcached. So you get the cache plus key value, and you can still extend it to a document database with a flexible data model with JSON. So apart from that, there is one key feature which is very unique. Apart from when compared to the other competitors, we have an embedded database on your mobile. So it sits right onto your mobile, and we also have a sync management tool, which is a cloud-facing component which syncs up the data from your mobile device to the cluster, right? So Couchbase, what are its key features? So there are 4 core principles that we have in Couchbase. So first is the consistent performance. Since Couchbase has an embedded Memcached, so the performance, whatever you see, you would get in typical sub-millisecond and even in microseconds. And throughout the scale, which means that throughout the high load, you will have a consistent performance. Whichever load or whichever concurrent users, you will still have the performance with low latency, with high throughput, and it's super easy to add and expand the cluster with just a push of button, and it's high available. So which means that the cluster is up and running always. You don't have to take a machine down at any time. You don't have to take the cluster down. For example, if you want to take a machine down for hardware or a software maintenance, you don't need to take the entire cluster down. The cluster can be up and running. You can take one machine out, and then you can do the maintenance, and you can add it back to the cluster, and it can be up and running always. And flexible data model, as we discussed. So Couchbase is a document database which supports JSON, native JSON, and also SQL query against the JSON documents, which means that you will have a flexible data model based on JSON. So big data. So how does Couchbase fit into the big data game? So as you know, big data has two major components, one on operational, other one on analytical. So Couchbase fits into this NoSQL area where it's real-time online interactive applications where it needs the data real-time with low latency, where you have to cater millions of users at the same time, right? So whereas on the analytical side, for example on Hadoop, typically it's offline batch processing or crunching of data. So use cases. So this is a broad topic which I would like to talk on a separate meetup with the detailed discussions pointing out to various customers. So right now what I can say is, like as I mentioned, you can start with a session store, a profile store, and have more into it details on 360 degree feedback or 360 degree view from various sources, and expand it to a product catalog, expanding it to as a document database, and you can store content management data, storing the metadata of the content management tools, and also with the variety of informations flowing in from various sources, and also real-time big data. So if you want to have Couchbase as an operational layer, which I was talking about in the previous slide, so you can have the operational data piping into the big data ecosystem, and there are a number of connectors which are available to Hadoop, to Spark. You can leverage that, and Internet of Things. So we would be talking about that in the mobile. So how Couchbase can help in the IoT space and mobile applications. As I mentioned, Couchbase Lite is a product which sits on right onto your mobile. And fraud detection. Fraud detection is a key area, and most of your financial customers are using Couchbase as a fraud detection backend to store the data and to retrieve it. As you know, it is sensitive and it has to be reported real time for any fraud analysis. So caters to that. As I said, I will cover a little bit on this in the next meetup because this is a very broad topic. So what makes Couchbase unique? So this is, again, as I mentioned, Couchbase, as you saw in the previous slides, is a multi-purpose. It's not just a cache, it's not just a key value, it's not just a document or a mobile database. It's a combination of cache, key value, and document. And along with that, like you have a capability to sync with a mobile, which is a lightweight component, and consistent performance. So as I mentioned, so this is a sub-millisecond latency with a high throughput and memory-centric architecture. And on top of it, we also have cross data center replication, which we call it as XTCR, where you can have the data being replicated to a remote site for disaster recovery and for the data locality. So that's Couchbase is the only solution which has the in-memory transfer for replication and always available, as I mentioned. So you don't have to take the cluster down at any time. So if you properly size the cluster, it should be up and running always. Even if a node goes down, cluster should be available with its capability of replication and DR planning. And we have an enterprise web console, which is super easy to add and deploy, manage and administer the cluster. And as I said, adding a node to a Couchbase cluster is super easy. All you have to do is just a click of a button and push a rebalance button. So it's as easy. So let's go a little deep into the architecture part. So the high-level architecture on a single node. So there are two core components. One is a data manager and the other one is a cluster manager. So data manager is responsible for holding the data, as the name indicates, and the cluster manager is responsible for managing the nodes in the cluster and for the rebalance and the data distribution part. So this component data manager is actually written in C++, and the cluster manager is written in Erlang. So with 4.0 we have got a few independent services that's running. So that's a data service, index service, and query service. So one unique thing about Couchbase is it's a true master multi-master solution. There is no slave in Couchbase. So all the nodes are identical until 4.0. With 4.0, we are having these three new services: data service, index service, and query service. So which means that you can scale based on your requirements. For example, I can add more nodes for index service. I can talk about what is index service, what is data service, but you can have few nodes having to play certain service available to that particular node alone, which means that you can have 3 nodes for data service, 1 node for index, and 1 node for query, right? So how it works is data service handles the basic get and set operations for Couchbase. So the basic get operations, basic CERD operations go through the data service, and you have a managed cache layer, a memory layer, and a storage layer. And for query service, we have a query engine. So with 4.0, as I mentioned, so we have something called Nickel, that is pronounced N1QL. So that is like a SQL for documents. So you will have a same SQL syntax. So you can run against Couchbase, and you can retrieve the data like how you retrieve from an RDBMS system. So you run the query on the query service node. So this query service node has a query engine, so which in turn prepares the plan how to execute the query, how to retrieve the data. And there is an index service which is responsible for a global secondary index. In Couchbase we have a global secondary index. So this index service is exclusively for the global secondary index. So it again has an indexing engine, so which basically indexes the secondary index. So it does have a managed cache and a storage layer. So as I said, you can scale based on the requirements, and you can actually have different nodes playing each other independently, and you can scale it based on the requirements. So you can scale independently on these things. That's why we call it as multi-dimensional scaling, which is pretty unique. So let's look a little internal to the cluster manager. So the cluster manager is actually responsible for the UI, REST interfaces. So you will get a near real-time graphs in the console. If you go to the Couchbase web console, you will see the graphs, the statistics. So all these things are managed by the cluster manager. So you have a UI, and we have a REST interface which is available. So that is exposed as a REST API. So you can actually develop custom applications on top of REST API. You can gather information. You can plot graphs based on the data that you obtain from the REST API. So configuration, administration, coordinating on cluster rebalancing, all these things are managed by the cluster manager component. Process monitoring, statistics, data processing. If there is no data processing, obviously there is some issue with the cluster manager component. The data processing is the data for the console, the web console which I'm talking about. So as I mentioned, it's written in Erlang, OTP code base, developed by Ericsson. So node manager, as I mentioned, we have data service, gets and sets for individual documents, and distributed secondary index for views, and index service for global secondary index, index maintenance and provision, query service for Nickel, which is like a superset for SQL for JSON. Execution plans, as I mentioned, and index coordination. So it's written in C, C++. Right now we are working on getting into Go. Sorry. So it's pretty fast, memory efficient, even with larger footprints. That's what we are working on. So multi-dimensional scaling. So as I mentioned, so you can have a single node with having all the services running, or you can have just the data service, just the index service. For example, you can have a powerful machine with more CPU cores as an indexing service machine, and you can have more memory with medium CPU for data, right? So you can scale it accordingly based on the requirements. But still, there is no master slave. It's all coordinated based on the scaling. Like if you have like 2 machines, you'll have an active copy of it. And when you have 3 machines, it's all the 3 are masters. So as I mentioned, you can have varying hardware capacities per node, and you can tune it accordingly. So this is like an example where you have all the 3 services running on all the nodes. Or what I can do is I can isolate, saying that the first 2 nodes can have the query service, the 3rd and 4th node can have indexing, and the rest of the nodes can have the data service. And you can scale independently for the best hardware, for best service type. So read operation, let's see how the read operation works. So Couchbase has a smart client. So smart client in the sense, the client of Couchbase is aware where the data lives. So I don't need to ask any coordinator, or I don't need to ask any master where the data lives, or where I should write the data, where I should read the data. So I'll talk about how it gets that smartness, but let's see how the basic read operation works, right? So now let's imagine that the application server knows that this node is the right node for reading a particular document. So I have a doc ID, that's doc1, which is the key. So let's see how it actually fetches the data. So if you see the Couchbase cluster, as I said, there are 2 layers here. There is a managed cache, which has the data in memory, and there is a disk, the data available in disk. So there are 2 queues. One is a replication queue, the other one is a disk queue. The replication queue, which is sent for other nodes in the cluster for replication. For when you add more replicas to a bucket, or I'll talk about it a little later, what is a bucket. So when you have more data, when you have replicas, so the data will flow to the replication queue. As soon as you have a data writing into it, so it goes to a replication queue and a disk queue. So here, it's a read operation. So it's as simple as I said, Couchbase client is a smart client. So it knows where the data lives. So all it has to do is give the key ID or the object ID. So it goes here, it fetches from the managed cache. So there is no disk involved here. There is no replication queue or the disk queue involved here, because the data is available in the managed cache. So obviously you can fetch it from the memory when you have the data from memory, right? So write operation, if you see, there is 2 copies which goes here. So one to the replication queue and another one to the disk queue. So the disk queue, you have a copy in memory and you have a copy in disk. And there is one more copy which left to the replication queue to the other nodes for replicas. So you can have replicas like based on your requirements. So based on the configurations. So it goes to the respective queue. So it can be 1 or more. So let's see how the data is being saved. So Couchbase is an append-only file system. So which means that all the deletes, all the updates goes through sequential, and let's see how it actually works. So let's look into a document which has a key as 1 and the value is ABC. So you have key 2 with value as DF, and key 3 value is XYZ. So you're going to update some document here, okay? So it's in the current state, so let's update. So you're going to update the key 1 with some new value. Instead of ABC, you're going to rewrite it to 1, 2, 3. So what's going to happen is, It's not going to straight away go ahead and replace the value. It's going to mark it for deleted and it's going to add a new value. Okay, we have seen that key 1, which is again rewritten over there with a new value, regardless of whatever the previous value is. So all these things. So now let's see, the key 2 is updated. So the old value was DEF. Right now we have 456. So it's now updated. So the process of compaction releases or removes the older entry. So this is just to avoid any overhead. So you can configure the compaction, which we would be talking about in later meetups. So let's see how the update operation works. So update operation, as you see, is not much of difference between a write and an update, right? So let's see what is a cache ejection. So let's start writing into the data. So the application server keeps writing some data. Let's see what happens. If it's getting full, the managed cache is getting full. So obviously it's going to eject the data to the disk. So you don't have a doc 1 here because it is ejected to the disk, right? So let's see how we read it. So now if you're going to do a get, what's going to happen? It's going to try to read from memory, but we don't have it from memory, so it has to fetch from the disk. As simple as that. So it's going to fetch disk queue, manage cache, and it's going to go back, right? So if you have noticed, now the document is back to the cache, right? And then document is pushed to the app server, right, for a read operation. So this is a typical cache miss scenario. So in an ideal scenario, you have to configure a cluster in such a way that you have less cache miss for optimal performance, so that you don't have to hit the disk, right? So you have to size your cluster accordingly, right? So typically we start with 100% document in memory. So if it goes beyond that, it starts ejecting the data, all right? So if it's not able to handle it, it's not going to refresh. So it's based on the least recently used, right? So it's going to kick off that particular document out of, and it's not going to get it back to the memory unless until it's been asked for, right? Because there's no point in putting it back to the memory, right? Oh, I have few things. Maybe if you can reserve your questions, that will be great. Appreciate it, because I'm running short of time. Okay, so how it actually works? Auto sharding. So Couchbase supports this auto sharding. So application wise, you don't have to worry about sharding the cluster, how my data will be distributed, how you're going to access. So we have a mechanism called a bucket to store the data. It is not identical to tables that many people will think about it, but it's actually a logical and unique key space. You can have dissimilar documents inside a same bucket. So I would typically recommend, or I would quote, it's like a file and cabinet. You can have multiple files with the various types inside a same cabinet, right? So you can have a similar stuff in a bucket. You can have a document. You can have a JSON document which talks about sales. You can have something which talks about marketing, right, inside a same bucket. So each bucket is actually classified into 1024 V buckets, virtual buckets. So and then what we do is we just shuffle these 1024 V buckets into the cluster, right? So each node in a particular cluster will own a set of V buckets. So now let's go back to the point, how Couchbase client is a smart client, right? So I was mentioning that Couchbase client is a smart client because if you do a little zoom into the app server, you could see that there is an SDK component which sits onto the application server, and there is a cluster map, right? So cluster map is like a table of contents or an index where it can tell where the data lives. Okay, so what it does is, for example, if I need to have a key, if I need to do a get operation, right? So I have a key, I hash the key with CRC hashing algorithm. So I get a map, I get a value for that. Okay, so it should be typically in between this 0 to 1024. So all I have to do is, okay, so which V bucket it corresponds to. So if you hash a key, you will get a V bucket ID. So all you have to do is where the V bucket ID lives. Okay, so this cluster map will have a reference. Okay, V bucket number 101. So it goes to node number 3. Okay, all you have to do is, okay, now node number 3. So application server can directly talk to the node number 3, right? Get the data out of it. So thereby, it's pretty smart. And even if the cluster changes, what happens if you add more nodes, right? What happens if a node goes down? It's still handled, because as soon as the cluster is changed, as soon as the cluster becomes normal, as soon as the cluster is healthy, it's not doing any of the other operational stuff. The cluster map will be updated or will be sent to the client. So this is like 2 nodes added. That's again the same operations because it goes to a different node. So let's do some basic operations. Basic operation in the sense, as I said, like we have multiple application servers. Let's see how the data resides. As I said, in Couchbase you have an active copy and you have a replica copy. So the replica copy of this particular node will reside on the other nodes, and the active copy will be there, and this will contain the replica of the other actives. So that if this node goes down, we can actually promote the other machine to active, the data to be active. Okay, so let's add more nodes to the cluster. So as I said, so as soon as you add nodes, you could see some shuffling which is happening. You could see some nodes, some data being shuffled or being pushed to the new node, some active data and some replica data. So what happens is, you saw this cluster map was blinking, right? So which means that it's getting updated, that whenever you have some new nodes. So now you have a new node to be acting as a master or active, and a replica for something else, right? So it's all one operation. So all you have to do is just click a node and add it. All these things are handled by Couchbase internally, so you don't have to really worry about it. Let's see a failover. So let's see, like node 3 node goes down for some weird reasons, right? So what happens here? So the active copy is lost. So a portion of a data is not accessible. So how do I retrieve the data? So the active copy is down. So but there are some replica copies which are present here on the other nodes. So that's what we're going to do. So we're going to promote these replicas to active. We're just going to flip it. So what's going to happen? So if you see, active has been moved. Now you have a new active documents pointing to the new nodes. But there is one issue here. So what is the issue? So now we have got the replicas being promoted as active. So what happened to the replicas? Because the replica which was previously a replica is now an active. So you don't have a replica, right? So for that you can do a rebalance. So rebalance essentially will help you to add more replicas, to gain more replicas. Right? So right now the cluster is stable, so it's 100% accessible. But still, if you ask, hey, is this good enough? Right? So I would say, may not be. What happens if you get one more node goes down? You'll not be safe, right? So that's why we have to do a rebalance after that. That's actually a manual process. But that's not a very cumbersome, it's just a click of a button. So takeaways, I guess you don't need to worry about the hash partitioning, sharding. So all the sharding is done by Couchbase automatically. And there is no load balancer here, if you notice. The Couchbase client handles the load balance and distribution, right? Because it exactly knows where the data lives. So I don't have to worry about where the data is residing, how do I distribute the load, nothing. Failover, it can be automatic or it can be manual. You can activate the replicas, V buckets, or prevent split brain. Split brain, in case of only when you have two nodes or odd nodes, you will have the split brain. Otherwise, you don't, because like what happens if the network cable is unplugged and if the two nodes is trying to fail over each other, right? So that's why it's a split brain scenario. But ideally, we don't recommend having two nodes in the cluster. Either it has to be a 3-node as a minimum. So, and we also have something called replica reads. So during a failover, if you are trying to access a data and it's not available for some reason, okay, so maybe the node is down, right, but the failover has not been activated, so you can do a replica read instantly, right? So that can save some time from your application, and you can actually do a little exception caching for that. Okay, so full cluster architecture, as I discussed, right? So we have different services running on these boxes. So you can actually, it's like a knob, you can actually switch it on and off. Like you can have data service, you can have index service, query service on nodes. So here I have the first two nodes are having data service, the other two index query service. So one more key differentiator is nickel. So it's been pronounced as nickel, but it's written as N1QL. That's first normal form, just to denote that. So it's a next generation NoSQL query language for JSON. So you can run a SQL query against the JSON documents. You can do joins in documents, and the commands, if you see, it's pretty simple. Just like your SQL, you can do select star from where and order, right? And there are ODBC, JDBC drivers available for BI tools for reporting. You can do that. So as I mentioned, so extended support, and we also have a support for nested and hierarchical data structures within JSON. So it can understand, and you can actually query based on the nested structure. So with the 4.1, there is a new version which was released yesterday. So which has an update for updates using nickel. So earlier we were using nickel for running queries, running joins. Now we can update using SQL commands, not just retrieving it. You can actually manipulate using update. So these are some examples. You can. There is a link available. I'll maybe share it end of the presentation. There is an online tutorial available, so you can actually play around with the SQL commands. So I'll share it later. So now let's move on to the QA. Any questions? I guess I was running a little too fast. Maybe like if you have any questions, we can talk about it.
It's on the main
On. Sorry, one question. Yep. You said the 4.0 version it supports multi-dimensional.
Yeah, multi-dimensional.
So what makes it to?
What means?
So I was trying to get more picture on why it's multi-dimensional suddenly in the 4th, not on the previous.
Okay. So with the previous versions, as I said, right? So there is no master-slave architecture. All the nodes are identical. Okay, so all the nodes were having only data service. So there is no global secondary index in the previous versions. Okay, so it was just a key value in a document store, and there was no nickel in the previous versions. So only with 4.0 you have a multi-dimensional scaling and you have a support for nickel, right? So when I say multi-dimensional, which means that I can still have like 3 nodes and I can scale it without affecting the data. Okay, for example, you see you are getting a lot of queries, right? You see you have more data to be indexed, so you can have a bigger, larger machine to do indexing. Whereas you can still have the data, you don't have to disturb the data anyway. Okay, you can scale it independently. So that's why we have like it is like a 3-dimensional, but the reason why we put it as multi-dimensional is we're going to have something in the future to have one more scaling, right? So that's why we kept it as multi-dimensional scaling. No. See, it's a horizontal on maybe 3 degrees. One is on the data, one is on indexing, and one is on the query. Right? So it's a 3-dimensional, I would say. Right now it's 3-dimensional. Yeah.
And I think it's very basic question.
Yeah,
Still,
sure.
like people say key value and document, but looking at the higher end, it says even the document is basically a like kind of key referred to a document.
Of course, yeah.
So what is or when key value, when document, what is the base difference?
Yeah, sure. The basic difference is like if you have a very simple key value, which means that hey, I have a user and a password, right? So user is actually you have a user ID and you have an encrypted password. Okay, so I don't have any complications in that. It's just an object, so it can be a key or an object ID. Okay, so the object is an object ID and an object, right? And when I say document, so I can have some more attributes to it. Right? I can have a JSON document. I can give more properties. I can give more schema into it, right? So it's ideally it's like a key plus values, right? Or multi-dimensional values inside that. Or I shouldn't say multi-dimensional. It's like key and values, right? So that's how it is. And typically we represent it is in JSON. So if you have it in JSON, it's like a document store. Or if I have it just like a key and a value, it's just a key value store. So.
The third thing is we talked about sync management and the 3 different services. Just wondering like who takes care of the sync management in this resource?
Yes, we're going to talk about it. Okay, the session is not over yet, guys. So we have one more component. So this is a basic introduction. Most of the people might already been aware of what is Couchbase. So we're going to talk about Couchbase Mobile. So where we'll be talking about the 3 major components. Right. So we'll be talking about it.
And we talked about this nickel, right?
Nickel, yeah.
Yeah, nickel. So I know SQL is a standard and all the databases follow this standard. So is it nickel is kind of a standard or it is specific to Couch? How it is?
So this is like a superset. Okay, so which means that you can have the same SQL syntax, same SQL commands. On top of that, you will get some more commands. Okay, so that some more commands would be specific to Couchbase, but the SQL commands, whatever I was showing you, that's pretty standard, right?
Yeah. And since like in the beginning we talked about like it doesn't have a structure. If you introduce a new column, there is no schema change, everything.
Yeah.
But from the nickel perspective, how I was not able to. Maybe I'm just comparing with the SQL, I guess.
Okay.
So how the SQL compiles, because few data will have new field, but few may not have. How it works there?
Yeah. So typically we put a check before doing anything, right? So as I said, in buckets you can have dissimilar documents with different types, right? So you can actually tag it. Say doc type is this, doc type is that. So you do an operation only if it matches that particular condition. If it matches that particular schema, then do it. Otherwise, it's going to ignore it.
Okay. Yeah. And we also talked about how it directly fetches from the cache or this Couch smart client. I believe there will be some fragmentation issues and all, right?
No, see, it's actually we manage the complete caching layer, right? So as I said, it's a drop-in replacement for memcached, right? So we turn off the huge pages, transparent huge pages, and then the entire quota, we allocate a quota for a particular bucket in memory. Say that hey, I need like 5 gig for this particular bucket.
Okay.
So we manage that. So we would not have any issues apart from that. You will have issues if you are going to go beyond that.
Okay.
Right. As I said, if you're going to go beyond that 100% limit of your capacity, then there are certain symptoms. So we will be talking about in detail in the coming sessions how we'll be what are the symptoms, what are the mitigations, how do we manage it, how do we size the cluster. So there are plenty of interesting things which are coming up. Since it's the first meetup, I want to give a basic introduction. So
Okay. Yeah. I think I.
thank you. Any other questions?
Mic use பண்ண சொல்றேன்.
mobile client. Obviously, you can't expect the mobile to be
Yeah. Of course.
Just wanted to understand how it handles that. Maybe
Do you guys want to answer the question? So I can answer it, but I want to give this chance to Anish. Yeah.
Basically, the mobile application it works in disconnected mode also. And if the sync or the server side cloud component is not available, that change remains in the device database, and it waits for the cloud component to be available quickly. And we have a demo where we display that. So it will remain in the client ready to be synced, and when the cloud component becomes available, it automatically syncs. The same applies to the data which is supposed to be pulled down from the server.
you're talking about the
Couchbase, the mobile component, the cloud sync component.
We will talk about the mobile component in the next presentation. So I'll also answer some questions. So after that, okay. So anything on the server side? Yeah, please go ahead.
Can you use the mic?
Yeah.
There will be someone who will release the memory, right?
No, can you repeat the question? I didn't get it
If
fully.
I update some node.
Okay.
Okay, so
Update in the sense you're going to add a node to a cluster. That's
no,
what you're.
I'm updating a node. I'm updating a value. So the older is
Oh,
gonna be
value.
deleted.
Okay,
Yeah.
okay.
The older is going to be deleted and newer,
Yeah,
another new one will coming for that.
It'll be marked for deletion, by the way. Yeah.
Yeah, so there will be someone who will release the memory, right? I mean, it's storing in disk. So there will be someone. So is there any mechanism who can?
See, it's all managed automatically, which means that, see, the compaction process is actually on the disk layer. It's only on the persistence layer, okay? Memory layer, it's replaced, okay? So memory layer, you will get only the new value, okay? Because the disk is actually expensive operation, okay? So that's why we were doing this compaction in NoSQL. It's pretty much similar to Cassandra and other NoSQL technologies, how the compaction actually works, right? So in memory, you don't have to worry about it. Memory, it's an update, direct update. You don't have the old value or the compaction, whatever I was talking about. It's only applicable for the persistence layer.
So that's why it starts from terabyte.
Pardon me?
I mean that memory things for NoSQL, it will start from terabyte and all this.
It depends on your data set, how much you're going to have, how much record, how do you size your cluster. So typically, one thing I can answer this. So disk has to be a little larger than the memory.
Exactly.
Of course,
Because
yeah.
if you have more update means it will take the space.
Of course, yeah. So you need to size your cluster in such a way that you have room for handling more than what is there in the memory.
And
Right.
how about the storing? Is it linked list or queue? Because if I'm searching for some index, it is getting me the data. So I'm thinking it's order of n. I'm not very sure. It's order of n or 1 or log n.
I'll have to check it out. I can maybe check it out and
Okay,
answer.
I'm assuming it's like order of n, the type complexity. So how it is storing? Is it a linked list or circular queue?
No, it's actually a B plus tree, I guess. No, it's you are asking about how it's being
Yeah,
stored,
in,
right?
memory,
Yeah, I can check it out. On memory or disk?
Memory. I mean, that's how it is storing. Where's the data structure for that?
Okay, I can confirm that. Okay. So yeah. Any other questions? Good. Thanks everyone.